Hello. All right. Very interesting panel earlier today, and actually, I think it's going to be an interesting convergence. Very quickly about myself, Franz Saint-Elamy. I am President and COO of LeaderTech, but I also am Chairman of University of Montreal, as well as Chancellor as well. University of Montreal, if you don't know, the University of Montreal is actually one of the largest French-speaking universities in the world, research universities. But today we'll focus on LeaderTech. See if this works. Today we'll be talking a little bit about LeaderTech, but more or less about what are the challenges to getting to more autonomy, more levels of autonomy. And then what are some of the things that we can do to actually help with this transition? So quickly about LeaderTech. The company was founded in 2007 as a research project from the National Institute of Optics in Quebec City. Today we're a lot more than where we started in 2007. We deliver sensor fusion software, environmental sensing solutions that helps really address the challenges of transitioning from lower levels of autonomy to higher levels of autonomy. We'll talk about that in a minute. But, autonomy is an interesting topic. Where are we today, on this road? I like to make this comparison of making this chasm, this transition from level 2 to level 3, driver in the loop, driver out of the loop. It's a huge gap between where we are today and where we are trying to get to. But let's go look a little bit about go back in the history. So 3 years ago, University of Richmond actually demonstrated that rats could actually learn fairly quickly to drive a vehicle, actually, to operate on the road. But going back many years ago, Mercedes-Benz did this Prometheus project. Actually, they had the Vita car, which was the Vision Information Technology Assistance. And this project demonstrated actually you could drive many kilometers, actually almost 2,000 kilometers, with fully autonomous features integrated into the vehicle. That's more than 25 years ago. And what happened since then? So we've had several car manufacturers, several projects, in fact, have launched. More recently, there was the Nissan limited quantities, about 100. You could only get them in Japan, very specific. More recently, the Mercedes came back again and announced this Drive Pilot, which is a highway pilot, low speed, 60 kilometers per hour, only in Germany again, so very limited. But let's go back. I love animals, so let's go back to animals again. Not too far from here, actually, the Ben Gurion University actually, demonstrated that fish can actually learn fairly quickly in a short time frame to actually operate a vehicle on the road. It's kind of interesting. But, the fish is about 1/20th the intelligence of a rat and obviously 15,000th of a human. So you can see even in very specific use cases, you can actually train the fish with rewards on how to efficiently operate the vehicle in different obstacles to create a drive pattern. And it's kind of interesting because if we can teach a fish how to do that, why can't we get autonomous driving on the road much more than we have today? Because this has been done. In many scenarios. And in fact, I can even show you another example where a dog actually is on a racetrack. We teach the dog on how to operate the vehicle safely as well. So, what are some of those challenges, right? The things that this fish was, aptly able to execute in a very short time frame, really it's about perception, planning, and obviously movement and control of the movement. So what are some of those challenges? Okay, so first of all, sensing is a challenge. So, obviously cameras, they have challenges, obviously, in these difficult weather conditions or lighting conditions. Radar, it's commonly known. Radar, actually, in this case, radar has very good performance in degraded environments, but understanding the scene is a challenge. LiDAR, on the other hand, LiDAR actually is immune to lighting conditions, but resolution remains a challenge. And so each of these sensor nodes, actually, they bring their own strengths, but they also bring their own weaknesses. But what about path planning? So path planning is actually very challenging. It's all nice if you're in Israel, where it's pretty much nice most of the time, or if you're in Arizona or California. But if you live where I live, it snows a lot. There's a lot of snow. 3 feet of snow is quite normal. And so the vehicle has to be able to adequately operate. And basic things as where are the lanes, finding those lanes is challenging. Another scenario is, understanding where, is the vehicle parked or is it stopped? It's quite important to be able to dissociate these things, even in common environments, just like around a parking lot. Understanding the intentions. Another challenge that's really trying to understand the intention. What will they do? What would the pedestrians? Will they stop? Will they go? So these are common challenges. Are they? Should we embark in the curb or not? Should we engage or should we stay? So these are some of the common challenges. There's also, perception. So first of all, what is perception? It's really about understanding the environment, making decisions on, from whatever the radar, the camera, or the LiDAR, or any other sensor node that actually provides in, turn that into, identifying, classifying, segmenting those objects. So making an understanding, turning into a human way of understanding the environment. And then from there, obviously, you have be able to better plan. So you want to have the most efficient path planning, efficient in terms of time and cost. And then you want to also have a very robust environment that really allows you to do that in order to be able to plan, to actuate or do an action. So this environmental, excuse me, I gotta go back. Sorry about that. There it is. I found it. Sorry. So what I mean by that is there are challenges with respect to existing incumbent legacy systems, which are based on typically object perception, object-based perception. So what is object-based perception? It's really about each sensor has its own intelligence. So the camera comes with its own perception stack. The radar does the same, the LiDAR does the same, and then everything gets fused then back into an environmental model. The challenge with that, it's very costly. It gives it creates inefficiencies in terms of the system architecture. The holy grail for automotive OEMs, and particularly some tier ones as well, is really to be able to disaggregate the sensor, the software from the hardware. So this disaggregation really allows them to source the hardware from the software independently, and creates a much more elegant system, gives you far more flexibility. But there are some really good reasons for having a software-based platform, based on raw data fusion. So let's talk a little bit about how we do that. Low-level fusion has many, many benefits. But the way we do low-level fusion at LeaderTech is really we take the raw inputs from the sensors immediately, and then we fuse them immediately. We create this abstracted layer. And then from there, we apply machine learning, we apply the neural nets to really create what we call the most robust environmental model. You want a 3D or color 3D rich environmental model that is robust, that gives you all the necessary information so that you can actually make the efficient path planning that I talked about earlier. Why this is important? Because once you've fused that environment, even if the sensors change a little bit, or the orientation of the sensors, you don't have to retrain your model that much. The perception remains the same. There's still a degree of fidelity from that perception. And there are many benefits of this architecture. I'll show you some of those examples, for example. So the scalable architecture, really about a single architecture that can scale from single sensor to multiple sensors to tens of sensors, and really allows you to have this hardware abstracted or hardware independent software model that is rich, that is independent of sensors, independent of ECU or processors, and really allows you to have a degree of flexibility and performance that you wouldn't get with object fusion. And don't take my words for it. Actually, independent data. This is new scenes from Aptiv. Camera, radar-based fusion, based detection. We come out on top for a couple of years now. Actually, with different flavors of software, we even improve our performance from the previous. So we have the two best generations of performance based on new scene. Another scenario is, degraded performance. I mean, sensors, they get into scenarios where they get degraded, and it's very important to have that reliability in terms of performance in situations where blinding light, or you're coming out of these extremely dark to extremely bright scenarios where the sensor has to adjust, and you still need to be able to detect even though the camera doesn't detect it. And the reason being is, even if the camera doesn't see it, but it's still in the scene, and the camera comes out with some information, and by fusing the camera and the radar data, you can actually get a lot more out of the system. Redundancy, that's another situation that is fairly common. So the sensor fails, and if the sensor fails, you still need, if the camera isn't there, one of those sensors, you still need to be able to detect what's in the scene. That's a safety measure. It's important that you have this capability built in. And I talked about comprehensive environmental model, meaning that it has to be as rich as possible, to have as much information in the model as possible, so that actually you can enable, as I mentioned earlier, the most efficient path planning, which leads you to a more valuable feature set. And we also have a lot of experience. I talked about, us having vehicles and operations in Canada in harsh, uncommon conditions. Same thing, we have vehicles in Israel, in Germany. We have infrastructure as well in China. So being able to actually operate in different adverse environments, and being able to operate in those obscene environments or difficult environments is very important to create the most robust system. So in conclusion, I think the most important thing is after many, many delays, we are really at this point where the industry is finally reaching a point where we are making progress towards level 3. And despite the challenges, we expect to see more deployments over the coming years. And essentially, despite progress, obviously challenges still remain in sensor fusion, in sensor perception, and path planning. And effective sensor fusion is necessary in order to overcome these challenges. And as I just demonstrated to you, we have many years of experience in developing these unique sensor fusion technologies, and they will be deployed fairly shortly in vehicles over the coming years. So I thank you for your attention today, and enjoy the rest of the show. Thank you.